Hi, welcome to our lecture videos about mathematics. In this video, we will talk about the foundation of mathematics, which is the sets. The foundation of mathematics starts with a basic understanding of sets, which was introduced by George Cantor. Set is actually a collection of well-defined objects. Members of the set are called elements. A set is designated with a capital letter enclosed with a braces, and its elements are separated with a comma. The elements that are written in the set can be in any order but cannot be repeated. Let us have this as our example. Set A is equal to 1, 2, 3, 4, 5. A is the name of the set. 1, 2, 3, 4, 5 are members or elements of set A. Now, let us discuss the basic properties of set. Number one, the change in order of writing the elements does not make any changes in the set. In other words, the order in which the elements of the set are written is not important. Thus, the set ABC can also be written as ACB or BCA or BAC or CAB or CAB. Another example is set A is equal to set 4, 6, 7, 8 is the same if we are going to write this as set A is equal to 8, 4, 9, 7, 6 or set 4, 6, 7, 8, 9 or set 8, 4, 9, 7, 6 and so on. This is similar to the set WXYZ can be written as equal to the set XZWY or set ZWXY and so on. Another basic properties of set is this one. If one or many elements of the set are repeated, the set remains the same. In other words, the elements of the set should be distinct or it should be unique. So, if any element of a set is a repeated number of times in the set, we consider it a single element. For example, set A is equal to 5, 6, 7, 6, 8, 5, 9. Notice in set A, we have 2, 6, or the 6 appeared twice. So we are going to erase the duplicates because we are going to consider this as a single element. So we are going to rewrite this and finalize the set, and set A will become 5, 6, 7, 8, 9. Another example is set B is equal to 1, 1, 2, 2, 3, 3, 4, 4, and 4. And we are going to remove the duplicates, and we are going to finalize set B as equal to 1, 2, 3, and 4. The set of letters in the word Google. Now, if we are going to spell this out, we have Google. And there are repeated letters or repeated elements, and we are going to consider only one of those repeated elements. So to finalize this, so we only have a set of GOLE. In general, the elements of a set are not repeated. Thus, if T is a set of letters in the word moon, then T is equal to the set of MON. There are two U's in the word moon, but it is written in the set only once. Thus, if U is the set of letters of the word committee, then we are going to finalize this as U is equal to the set of COMTE. Now, let us discuss notations of set. Physically, membership in a set. Membership in a set is indicated by the symbol epsilon, or it's like a letter E or a big letter E. And non-membership is epsilon with a slash. Thus, X epsilon A means that element X is a member of the set A. Read simply as X is an element of A and Y is not an element of A. That means Y does not belong to set A. For example, set A is equal to 1, 2, 3, 4, 5. Thus, we can write that 1 is an element of A, 2 is an element of A, but 6 is not an element of A. The next thing that we are going to talk about is the representation of a set. The first one is the statement form method. Here, a well-defined description of the elements of the set is given and then enclose this in a curly brackets. For example, set A is the set of odd numbers less than 7 can be written as set A is equal to the set of odd numbers less than 7. So this is how we make the statement form method. Example number 2. Set C is the set of colors of rainbow can be written as C is equal to the set of the colors of rainbow. Example number 3. The set of real numbers can be written as R is equal to the set of real numbers, or we will enclose R with curly brackets because the symbol of real numbers is R. So this is how we are going to represent a set using the statement form method. The second method is known as the rooster method or the tabular method. In this method, all elements of the set are listed with a pair of brackets and are separated by commas. Example number 1. The set of vowels in English alphabet can be written as V is equal to the set of A, I, O, U. So we listed the vowels in the English alphabet. Example number 2. The set of positive natural numbers that are divisors of 12 can be written as Y is equal to the set of 1, 2, 3, 4, 6, and 12. And these numbers are the positive divisors of 12. Example number 3. The set of all letters in the word mathematics can be written as M is equal to the set of M, A, T, H, E, I, C, S. So this is the thing that we're going to do if we are asked to do the roster method or tabular method. We are going to list all the possible members of that particular set. The third way to represent a set is the set builder form or rule method. The elements of a set may be described without actually being listed. This is the rule method. In the set builder form, we indicate a set by enclosing in braces a descriptive phrase and agreeing that those objects and only those which have described properly are elements of the set. The general form is A is equal to the curly brackets, and the curly brackets has this X and then colon and then the descriptive phrase or property. Or it can be curly braces, and then inside that curly braces we have this X, and then we have this bar and then the descriptive property. Example number 1. Let P be the set of counting numbers greater than 12 can be written as what is shown below. And this will be read as P is the set of all X such that X is a counting number and greater than 12. Example number 2. Let E be the set of even numbers greater than 1 but less than 11 can be written as this one. P is the set of all X such that X is an even number greater than 1 but less than 11. So that is how we are going to write the set builder form. Example number 3. Let Z be the set of integers between -2 and +3. So this can be written as Z is the set of all X such that X is an element of Z. Z is the symbol for integers, or sometimes we use I, and X is greater than -2 but less than positive 3. Example number 4. Let y be the set of consonants of English alphabets. Y is the set of all x such that y is a consonant of English alphabet. So these are the 3 ways of representing a set. Now let us discuss the types of set. Number 1 is the finite sets. Elements can be counted. Example number 1. A set of counting numbers less than 6 is equal to set A is equal to 1, 2, 3, 4, 5. So we can count the number of elements in a single set. So in this set, we have 5 elements. Example number 2, a set of positive divisors of 12, which is equal to D is the set of 1, 2, 3, 4, 6, and 12. So we can have 6 elements of this particular set. The next type of set is the infinite sets. Elements can't be counted until the end because the number of elements are infinitely many. Example number 1, set of positive add integers. So if we have the positive add integers, we have 1, 3, 5, 7. And then to write this, after the comma, we will write 3 dots or the ellipsis, and that would mean the counting continues. Example number 2, a set of counting numbers. X is the set of 1, 2, 3, 4, 5, and then we'll write the 3 dots or the ellipsis. Again, that would mean the counting continues. The third type of set is the null set. It means that no elements in the set is called null set or empty set, denoted by the symbol open and close curly brackets, or we have this phi. An example for this is a set of whole numbers between 1 and 2. So we don't have a whole number between 1 and 2. So that is why W is equal to the null set or empty set. Example number 2, a set of number that are both add and even. So we don't have that one. That is why the set of n is equal to a null set or empty set. The next thing that we have here is the orders of set. The order of a set defines the number of elements counted in a finite set. So the order of the set means that we have to count how many elements inside a finite set. And this one describes the size of the set. It is also known as cardinality, symbolically denoted by n of A, which is read as the cardinality of A. Example number 1. What is the cardinality of A if A is equal to the set of English alphabet? We are aware that there are 26 letters in the English alphabet. That is why the cardinality of A is equal to 26. Example number 2. What is the cardinality of B if B is equal to the A, I, O, U? Looking at this example, we can see that there are 5 elements of this set. These are the vowels of the English alphabet. That is why the cardinality of B is equal to 5. However, if set A is infinite, then we write the cardinality of A is equal to infinity. Let us discuss other types of set. Number 1 is singleton sets. These are the sets with only one element. Say, for example, M be the set of all x such that x is an element of real numbers where x is greater than 2 but less than 4. With this type of set, the only element of this set is 3. So that is why M is equal to 3, and we consider this as a singleton set. Other type of sets are the equal sets. The two sets, A and B, are said to be equal if they have exactly the same elements. The order of elements do not matter. Example number 1, we have set A is equal to 1, 2, 3, 4, and set B is equal to 4, 3, 2, 1. So notice that all elements in set A can be found in set B, which are exactly identical, even if the order of the elements are not the same. Still, we consider this that A is equal to B. Example number 2, set C is equal to A, B, C, D, and set D is equal to A, B, D, E. So we have noticed that there are differences between the elements. Specifically, set A doesn't have an element of E, and set D doesn't have the element of C. So we can say that set C is not an equal set of set D. The next type of set is equivalent sets. The number of elements is the same for two different sets. Then they are called equivalent sets. The order of the sets does not matter here. So meaning, if you have two sets and they have the same cardinality, we can consider this as equivalent sets. Example, it is represented with the cardinality of A is equal to the cardinality of B, then we can say that A is congruent to B, or A is equivalent to B, and we are going to use the symbol of congruent, or sometimes we use the double arrowheads. Example, if A is equal to 1, 2, 3, 4, 5, and set B is equal to red, blue, orange, green, and black, the cardinality of A is 5 because there are 5 elements. The cardinality of B is 5 because there are 5 elements. That we can say that the cardinality of A is equal to the cardinality of B. Therefore, A is equivalent to B. Now, let us discuss more types of sets. We have here disjoint sets. Two sets, A and B, are said to be disjoints if they don't have any common element. For example, A is the set of all x such that x is a prime number, and B is the set of all x such that x is a composite number. Clearly, A and B do not have any element in common and are considered disjoint sets. The next type of set is the overlapping sets. Two sets, A and B, are said to be overlapping if they contain at least one element in common. For example, number 1, set A is equal to A, B, C, and D, and set B is equal to the A, E, O, U. And if you are going to look at the sets, so they have an intersection, or they have a common set. So to write this, we have A intersection B, or the intersection of A and B is equal to A. This A can be found in set A and can be found in set B. Example number 2. X is the set of all x such that x is an element of natural number where x is less than 4. And y is the set of all x such that x is an element of integers where x is greater than -1 but less than +4. So let us try to list down what are the elements of set X. So if we are going to list it down, we have X is equal to 1, 2, 3, and set Y will be equal to 0, 1, 2, 3. And the intersection of set X and Y are 1, 2, 3. That would be all for today. I hope you learned something. Bye-bye.